Alright guys, so pre-algebra lesson 1.3, this one's going to deal with increasing and decreasing sequences. So we saw that a sequence in the previous section was just an ordered set of terms. So now we'll just kind of expand upon that and get a couple more specific types. So if we take a look here, the first paragraph, an increasing sequence is a sequence of numbers where the value of the numbers is increasing. And a decreasing sequence is one where the value of the numbers is decreasing, right? So increasing, of course, means to get bigger, and to decrease means to get smaller. So let's take a look here at number one here. Examine the following sequences and state whether they are increasing or decreasing. And let's support our answer by describing the pattern. So pretty straightforward. Say, example A, 3, 6, 12, right? Those numbers are getting bigger, so this is an increasing sequence for sure. And the pattern, what does it appears to be happening to get from 3 to 6 and then from 6 to 12? It looks like we are just multiplying by 2. So when you multiply by a positive number, you're going to get a bigger number, thus an increasing sequence. Okay, part B there, 17 to 14, right? Then to 11, then to 8. So clearly the numbers are getting smaller. This would be a decreasing sequence. And what is the pattern there? We are subtracting 3 each time. Okay, and when you subtract a positive number, right, you're going to get a smaller answer. Okay, so can we provide an example of an increasing and a decreasing sequence? I'll leave that up to you guys. Just come up with one in your head and then kind of describe the pattern. Alright, hopefully everyone was able to come up with one of those. So let's take a look now. Let's see if we can complete the table. They give us a few more examples here, and we need to state if it's increasing or decreasing, and then give the next term and describe the pattern. So what do we got? We're going from 0, 5, 10, 15, so definitely increasing, right? Okay, and what would be next? Okay, well the pattern looks like we are adding 5, right? Maybe we can fill that in first. That will help us recognize that the next term in the sequence should be the number 20. Okay, how about the next one? We go from -8 to -4 to -2 to -1. Okay, is that increasing? Are the numbers getting bigger or smaller? Okay, and careful on this one. Since the numbers are negative, right, even though they look like they're getting smaller, this thing is actually increasing because the numbers are getting larger. They're getting like less negative, right? So anytime on a number line, if you're moving to the right, it's increasing. So to me, it looks like in this case we are dividing each by 2, right? So that is the pattern. So the next term in the sequence, if we took that -1 and we divided it by 2, -1 over 2, right? -1/2. Okay, the third one in the list here, we're going 1.5, 2.75, 4. So the numbers are definitely getting bigger. Now the question is, what is the pattern? Okay, we got some decimals in there, so it might not be quite as obvious. One little trick you can do if you want to see if there's a common addition or subtraction, what you can do is you can take, for example, the second term minus the first term, right? And let's just see what ends up happening. I'm going to throw a 0 in there after the 5, right? 1.50. And when we subtract those, it's telling me that's the difference in the terms. Okay, so to get from the one term to the other, okay, it's a difference of 1.25. Let's see if that pattern continues. To get from 2.75 to 4. So if I had 2.75, if I add the 1.25 to that, will that get me the next term of 4? Let's see, so we can add those. Right, and it appears to work. So it looks like our pattern in this case is we are adding 1.25 each time. Okay, so that would mean the next term, if we were at 4, if I added 1.25, I would be at 5.25. Okay, good. All right, next one, we're going from 1/8 to 1/4 to 1/2. So those numbers are getting larger, Okay, and we'll get more on fractions coming up soon, but those fractions are getting bigger, and it appears they're doubling, right? 1/8 to 1/4 to 1/2. So we are actually multiplying by 2. Okay, so that would mean from 1/2, if we times that by 2, we should end up with 1 full. Okay, and then let's see, for the last one here, let's give ourselves some room, erase some of this. We're going from 2 to 5/4 to 1/2. Okay, one thing you can do if you want to, let's think of these as decimals, right? So to go from 2, so 5/4, right? Let's think about 5/4 is really. So yeah, the 5/4 could be thought of, again, and we're going to get more into fractions in the next section, but just as a review, right? 5/4 is the same as 1 and 1/4, right? Because 4 goes into 5 one time with 1 left over. Okay, and 1 and 1/4 is 1.25. Okay, so I'm just kind of giving some options here if you don't like dealing with the fractions. Decimal equivalents can sometimes work out. And then, of course, the 1/2 is 0.5. So if you have the sequence written in decimal form, it might be easier for you guys to see what the pattern is. And the pattern is from 2 down to 1.25, we are actually just subtracting 0.75. Okay, and that pattern would continue there. So feel free to go decimal route. It does kind of sometimes make things easier. And again, if you're still a little struggling with the fractions, stay tuned next week. So the pattern's decreasing, and then to get from 1/2 to the next term, if we just subtracted 0.75 again, we should end up at negative 0.25. Okay, or negative 1/4 if you want to stick with the fractions as the original terms were given. All right, so that's just a couple examples of some patterns and sequences. Now, one other concept in this section is this idea of absolute value. And you'll see in the math terms there on the left, the absolute value of a number is its distance in units from 0 on a number line. Okay, and absolute value is always non-negative. Okay, and the reason for that is that distance itself, distance cannot be negative, right? You might be 10 feet from the door, but you would never say like you're negative 10 feet from the door. It depends on which side you're on, right? So if you want to think as a little visual here, here's 0 on a number line. Let's go 1, 2, 3. Let's go 1, 2, 3 in the negative direction, right? Both of those numbers, okay, if I'm sitting out at 3, the distance from -3 to 0, that distance is 3. Okay, same thing if I'm sitting over here, that distance from 0 to +3, they both have a distance of 3, right? So they both have an absolute value of 3. Okay, so let's take a look. We got a little example going, and we'll kind of work this out as it goes. Let's consider the sequence that uses absolute values of numerical expressions there. Okay, we have the absolute value of 5 minus 2, the absolute value of 5 minus 3, and so on. Okay, so the absolute value of 5 minus 2, right? So 5 minus 2 is 3. Let's see if we can zoom in and give us some space here. So this one is really just saying the absolute value of 3, okay, which is, how far away from 0 is 3? It's 3 units away. Okay, the absolute value, 5 minus 3 is 2, right? The absolute value of 2. How far away from 0 is 2? It's 2 units. Okay, 5 minus 4 is 1. Its absolute value, that's what the bars mean, its absolute value is 1. 5 minus 5, of course, is 0. The absolute value of 0, how far away is 0 from 0? It's 0 units away, right? It is itself. Okay, now let's see what happens. 5 minus 6, that's -1, right? Okay, what is the absolute value of -1? Think on a number line. How far away from 0 is -1? It's 1 unit away. It just happens to be to the left, but its distance, right, cannot be negative. Non-negative is 1 unit. And then 5 minus 7 is negative 2. Its distance from 0, negative 2 is only 2 units away from 0. Okay, so some people just kind of think like when you take the absolute value of something, you are just looking at the positive of whatever number is in there because it's a distance, right? And it's from 0. So what's going on with this sequence, right? Let's describe the pattern. Well, it seems to at first decrease, right? 3 down to 2, down to 1, down to 0 still. But then it starts to increase. Okay, so this thing would be a neither, right? This is not an increasing sequence or a decreasing sequence. It's kind of doing both. So this is a neither one. All right, number 5 here, let's see what we got to do. They want us to arrange the numbers below so they form an increasing sequence. Okay, then describe the pattern. So let's evaluate each of these on their own. So first one here, the absolute value of negative 16 times the absolute value of 5. Okay, well, the absolute value of negative 16, again, negative 16 is 16 units from 0. The absolute value of 5 is 5. 16 times 5 equals 80. Okay. Next one, we have the absolute value of negative 18 minus 2. So we need to simplify inside the absolute value first. So negative 18, right? Take away 2 more. We are at negative 20. Its absolute value, how far away is negative 20 from 0? It's 20 units away. Okay, next one. 3 minus 13. Okay, that is negative 10, right? We have not taken the absolute value yet, so I'm still going to write the bars. Now the absolute value of negative 10 is 10. Okay, next one. The absolute value of 38 plus the absolute value of negative 2. So the absolute value of 38 is just 38 plus the absolute value of negative 2. What's the absolute value of negative 2? 2. And now we can do 38 plus 2 is 40. And finally, we got a little fraction in there. Negative 10 over 2 is negative 5, right? Now we didn't take an absolute value yet, so the absolute value bars are still there. What's the absolute value of negative 5? It's positive 5. Okay, so we got each value simplified. Now let's just write it as an increasing sequence. So we're going to put it in order. So we have the 5, then there's a 10, then I see a 20, then I see a 40, oops, and an 80. Okay. And what's the pattern? Does this thing have a pattern? Okay, it's definitely increasing. To get from 5 to 10, it looks like times 2 each case. All right, so moving along here. So number 6, let's take a look. We know that sequences do not always, or maybe we don't know, we're about to know, sequences do not always have to include mathematical operations. So if we look at these sequences below, let's give a verbal description. Let's see what's going on here and see if we can list the next couple terms. So we're going from 3.12 to 3.1212 to 3.121212. So it looks like they're kind of adding a 1, 2 at the end, right? So the next term, we have 1, 2, 1, 2, 1, 2. We would need another 1, 2, right? And then we would need to do that again. 1, 2, 1, 2, 1, 2, 1, 2. So that's 1, 2, 3, 4. We need another 1, 2. Okay, and then so on. I'm not going to take the time, but it looks like they're just adding a 0.12 at the end, an additional 0.12, not adding 0.12, but they're adding a 1, 2 at the end of the long decimal. Okay, so it's not really like a common thing that's being added to the number just because of the place value kind of thing. It's just, it's a pattern, but it's not like a set adding the same thing each time. Okay, same thing with part B. If you take a look, this pattern kind of looks clear. It looks like in the denominator they're adding an additional 2 spot down there. 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5, 6. Okay, but it's not like adding the same amount. They're just adding a 2 in a certain place value down there. Okay, so it's a pattern, not necessarily by adding a constant, like adding 3 or something like that. Okay, and part C should kind of illustrate that point a little bit too, right? It's going from 1 to 12 to 123. So I think the next number should be 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, right? So what I mean when I'm saying they're not adding like a constant amount, like the difference from 1 to 12 is really like adding 11, right? But to go from 12 to 123, we're not just adding 11 again, right? So it's not a common addition, but there's definitely a pattern there. Okay, next one, Z to Y to X to W. Looks like the alphabet backwards. Okay, so the next ones, and this is hard to do, be what? V, U, and T, right? Is that right? T, U, reading from right to left, T, U, V, W, X, Y, Z. Yeah, so that would be the next terms there. Okay, and now part E. This one's kind of tricky. Anyone think they got it? Kind of a weird one here. And I had to look it up. I didn't know what it was. I looked it up in the book. Those are the, let me give you the next few, see if you're right. Does that help? Okay, those are actually the first letters of the month. The months in a year, right? January, February, March, April, May, June, July. So again, I don't know. That would have taken me forever. I looked it up. Something like that I would not test you guys on, like just some random thing of you not seeing a pattern or whatever that they expect you to see or whatever. But just kind of a fun one. I mean, it's definitely a sequence, right? It's in order. Not increasing, not decreasing, first off, because it's dealing with letters, but just kind of a goofy little pattern there. All right, so we have seen different types of sequences, some increase, some decrease. We saw a little bit with absolute value. Let's go ahead and do some practice. Okay, so your assignment, this is page 14, will be to complete numbers 10 through 14.